Dear students, during this session, I want to discuss about the plotting of graph of electric field due to a positive point charge and a positive and a negative point charge. Let us try to plot the graph here. So, for a positive charge, if I see a charge q, if it is placed say along x axis and the charge q is at the origin. So, let us say this is the y axis, this is x axis for me, this is y axis for me. I want to plot the graph for the electric field along the x axis. If I take a point on the positive side of the origin along x axis, I know the electric field is varying inversely proportional to the square of the distance. Similarly, if I see the direction of electric field at this point, then this is along the positive direction electric field. Contrary to this point, if I take a point on the left side of the origin, I will see that the direction of the electric field is pointing towards the negative direction. In that case, I say that here, see, the direction is along the negative direction. I assume that this is less than 0. And here, since the electric field is in the positive direction, this I say like this. Now, when I try to plot the graph, I will see so let me say this is distance and this is electric field for me. Now, when electric field is represented by the vertical axis, so above origin this will be positive and below origin the electric field is on the other direction, opposite direction. So, if I consider any of the points on the right of the origin, I see that the electric field is pointing along this direction. I am going to consider this direction as positive. So, the electric field at any point is going to be represented by the E above the origin. And if I consider any of the point here on the left side of the origin, I find that the electric field is pointed towards the left hand direction and I am going to consider this direction as negative. So, therefore, the electric field will be represented here. This is the case. Now, at the very first, let me see on the right side. So, the distance of the point starts from 0, extends up to infinity. So, therefore, I say that this side, the distance is greater than 0 and less than infinity. In that case, when r is very close to 0, the value of electric field is very, very high, or as the value of r increases, distance of the point from the charge increases, the value of electric field will go on decreasing. When r approaches infinity, E will become 0. So, therefore, see, at infinity electric field approaches 0 and when distance is closer to the charge, it is in infinity. So, therefore, the graph is going to be like this on right side. If I see on the left hand side, when the point is very close or point can be from near to the origin, that is r is greater than 0 and it extends up to infinity. So, I will say this side r is greater than minus infinity and is less than 0. So, we cover all the points on the left hand side. So, as the value of r is very close to 0, then the electric field value is very high, but direction is in the opposite direction. So, when r is closer to 0, So electric field is very high, it's close to infinity, and when the point is far away, when the point is at infinity, we see that the electric field reduces to 0. So therefore, the graph here, the graph comes out to be like this. So this is the plotting of electric field due to a positive point charge on a graph. Let us move on. Let us try to plot the graph of electric field due to a negative charge. In that case, do you think that here the charge will be negative? If the charge is negative, then mind it, if we consider a point here, instead of having the direction of electric field here, the direction of electric field will be opposite. And at this point, the direction of electric field will be opposite, as you have studied already. In that case, see, this direction we treat it as positive, previously we treated, and therefore for us the electric field is positive, greater than 0, and here the electric field is less than 0. This point holds good the same, because you can have all points here from 0 up to infinity, so this is right. And similarly, on the left of the origin, we can have the collection of points which will lie in between 0 and minus infinity. For this, if I try to plot a graph, then let me plot here. Actually, we had a positive charge here. For this, we plotted the graph of electric field. This time, we are going to have a negative charge at the origin. And let us say this is our electric field here, which represents, and let this be the x-axis, the distance. So for the positive side, if we look at, the electric field direction is negative. So therefore, this will be the direction of electric field. When the value of r is very close to 0, the electric field is at infinity. It approaches infinity. And as the value of r is at infinity, the value of electric field approaches 0. So therefore, the graph goes this way. And if you look this way, electric field is in the positive direction. So this part of the vertical axis is going to represent my electric field. In that case, when r is very close to 0, electric field is approaching infinity. And when r is at infinity, the electric field is approaching 0. So therefore, this is how we plot the graph for electric field with respect to distance due to a point charge, negative point charge, and for positive point charge. Please make note of this. This is an important graph. Let's move on to solve a problem to calculate electric field. Let us assume that we have two charges or 2 point charges. Say. One is plus 3 microcoulomb, the other one is minus 3 microcoulomb. And these two charges are fixed at a distance of 20 centimeter. And I want to calculate what is the electric field right at the midpoint of the line joining the two charges. Let us see in the diagram. So therefore, see, I said one positive charge I have, and the other one is a negative charge. This is the line joining the two charges. So this is the negative charge. The value of this charge is minus 3 microcoulomb. And about this is plus 3 microcoulomb charge. The two charges are separated by a distance of 20 centimeter. I want to calculate what is the electric field due to these two charges at a point exactly midway between these two charges. So if the entire distance is 20 centimeter, it means that this point is at a distance of 10 centimeter from this charge, and from here it is 10 centimeter. I am going to calculate the net electric field in two ways. One, I will calculate the magnitude of the electric field and direction separately, and during the second method I will try to apply vector method to calculate the total magnetic field at the midpoint. So let me name the points. Let me say that this is point A, let me say this is point B, and I want the electric field to be calculated at point C. So first I want to calculate the magnitude of the electric field at point C. If that is the case, to calculate the magnitude, here at this point C, two electric fields are acting, one due to this positive charge, other one due to this negative charges. So because of this positive charge, I know that the electric field is acting in this direction. So therefore, let me say this is E plus. Next, I see because of this negative charge, at this point electric field is acting, and that electric field is also acting along the same direction. So let me put this way, this is the. So at point C, two electric fields are acting, electric field due to positive charge and electric field due to negative charge, both are in the same direction. Therefore, the total electric field will be sum of the two electric fields. So therefore, I want to calculate the magnitude of electric field E plus and E minus separately, and I want to find the sum of the two fields. In that case, E plus, that is electric field due to positive charge, this will be equal to, I know that expression we have already studied, K into the charge. Let me say this is Q1 for me, and let's say that this is charge Q2. So in that case, K into Q1 divided by distance square, which works out to be K, the value we know that 9 into 10 power 9 into Q1 is 3 microcoulomb. So let me say 3 micro 10 power minus 6 divided by square 10 centimeter. I hope you understand that we need to calculate or convert it into meter. So 10 into 10 power minus 2 the square, and this works out to be E plus is equal to, rather I prefer to keep as such because further calculation will be simpler. So I want to calculate what is the magnitude of the electric field due to negative charge, and this gives out K into Q2 by R square, which works out to be 9 into 10 power 9 into, I am trying to calculate magnitude, I am not going to consider the sign. So this happens to be 3 into 10 power minus 6, and the distance is same. So 10 into 10 power minus 2 whole square. The total electric field at C is the sum of the two electric fields. So similarly, these two are magnitudes, and I am going to find the sum of the two. As such, the net electric field is equal to the sum of the two, E plus plus E minus, which happens to be this. As you look at, see the magnitude, this and this, both are equal. If both are equal and I try to find the sum, if this is x, this is x, x plus x will be 2x. So as such, straight away I write 2 into any one of the two, 9 into 10 power 9 into 3 into 10 power minus 6 divided by 10 into 10 power minus 2 the whole square, which works out to be E is equal to 2 3s are 6, 9 6 are 54. So this happens to be 54 into 10 power 9, 10 power minus 6 works out to be 10 power 3 divided by 10 into 10 power minus 2 is 10 power minus 1. 10 power minus 1 whole square is 10 power minus 2. When I take it to the top, it happens to be 10 power plus 2. So let me write here 10 power minus 2, which gives me 54 into 10 power 5, and in turn this will give me 5.4 into, if I take this one, so I will get 10 power 6. E is Newton per coulomb. So this is the answer, 5.4 into 10 power 6 Newton per coulomb we tried to calculate using the magnitude. If this is the case, I said how to express this answer. I will say that the answer is, because electric field is a vector quantity, so therefore I will write the answer this way. E is equal to 5.4 into 10 power 6 Newton per Coulomb along, see the net electric field is acting along positive direction of x axis. So to me I can represent A to B. So along AB. This is one way to calculate. The second method I am going to use vector method to calculate the electric field. So to use vector method, what I am going to consider the line joining the two charges. I am going to consider this as x-axis for me. X-axis, if this is the x-axis, we are familiar. Using the unit vector I, we can represent the direction along x-axis this way. So in that case, I am going to calculate the electric field due to positive charge. So hopefully, see, I know the expression electric field is equal to 1 by 4 pi epsilon naught into charge divided by square of the magnitude into unit vector. This is the general vector expression we use to calculate the electric field in vector form. So let us try to calculate the electric field due to the positive charge. So E plus, this is a vector, this is equal to 1 by 4 pi epsilon naught. Usually we write K Q by R square for us. So this is R square into unit vector I. Unit vector I represent direction. So for us, because of this positive charge, this is the direction and this unit vector direction is I cap. So for us, this will be I cap. Now let us substitute the value. So this comes out to be K is 9 into 10 power 9 into charge is 3 microcoulomb 10 power minus 6 by distance square. This is 10 centimeter. So 10 into 10 power minus 2 the whole square into I cap. Similarly, for negative charge, the electric field at this point will be E minus vector. This is, for us, the expression is same, K Q by R square, unit vector I. So because of this negative charge, the direction of electric field is again towards the right hand side and the unit vector that represents the direction is I cap. So here too I can write I cap. So this happens to be 9 into 10 power 9 into 3 into 10 power minus 6 by 10 into 10 power minus 2 the whole square into I cap. Now the net electric field, when I try to find, I know that it is the vector sum of the two electric field due to positive and negative charges, and the two electric fields are acting along positive direction of x-axis given by I cap. So straight away I am going to find the sum. So when we work out the sum, it will be 2 into the same expression, magnitude we are going to get the same. So 2 times 9 into 10 power 9 into 3 into 10 power minus 6 divided by 10 into 10 power minus 2 the whole square into I cap, because I plus I will give me 2I, and that 2 is here, I cap is here, and this will work out E is equal to straight away 5.4 into 10 power 6 I cap Newton per Coulomb, and this is the answer in vector form. So here we need not write along AB, or separately representation of direction is not required because straight away we have represented the direction. Let us extend this problem. Now we calculated what is the electric field at this point. The other part is I want to first place a negative charge at point C, and the charge is minus 1.5 into 10 power 9 Coulomb. So if I place at this point, question is what will be the net force experienced by the charge minus 1.5 into 10 power minus 9 Coulomb placed at this point. So let us say the charge placed at C, so let me say QC, this value is minus 1.6 into 10 power, say minus 1.5, minus 1.5 into 10 power minus 9 coulomb. So if I place the charge here, the net force that the charge is going to experience, that will be equal to F is equal to Q into E. So let us substitute the value of charge Q and E. So the force F is equal to, charge is 1.5 into 10 power minus 9 into electric field at point C is 5.4 into 10 power 6, and this works out to be 15.5 into 5 is 75, and 4, 6, this comes out to be 81. So this works out to be 8.1 into 10 power minus 3 Newton per coulomb, and the force will be acting along BA. Along BA. I hope you understand, because this is a negative charge. When you place a negative charge here, then this will be experiencing force in the opposite direction to that of electric field. Negative charge you place, this positive charge will be attracting, and this negative charge will repel this one, so this charge will try to move along this direction in the opposite direction to that of the net electric field at this point C. Now this has been calculated using this first method. Using second method in vector form too, I can calculate. See, F is equal to Q into E. We have already studied while solving the problem in vector form, we will be placing the value of charge with the sign. So for our case, F is equal to, charge Q is for me minus 1.5. So minus 1.5 into 10 power minus 9 into E. E in vector form I already calculated, 5.4 into 10 power 6 I. So therefore 5.4 into 10 power 6 I cap. Now if I calculate this value, the magnitude is same as this case, however I am going to get minus 8.1 into 10 power minus 3 I cap. Now when we look at the solution here, see, F is equal to minus I cap. Positive I cap direction is this way, but negative of I cap represents this direction. So therefore the charge 1.5 placed at C will experience a force along the negative I direction. Let us move on to another problem. Let us suppose that we have an XY plane. At XY plane, let me say a point that has a position vector 2 I cap plus 3 j cap, and at that point a charge is placed of magnitude 50 microcoulomb, say. Let me put in the diagram here. Let me suppose that I have an XY plane. This is origin. I said 2 I cap 3 j cap, so this is the position. Let me say this position vector is R0, and at this point I have placed a charge of say 50 microcoulomb, and this charge is positive. There is a positive charge placed. Now this positive charge will produce electric field surrounding it. I want to calculate the value of electric field at a point on the plane 8I minus 5j. If 8I minus 5j, then 8I minus 5j, minus j is in this direction, so somewhere here the point is, and therefore let us say that this has a position vector of R, and this R I will put the values. So R0, this is 2 I cap plus 3 j cap. this R is equal to 8 I cap minus 5 J cap and a charge of 50 microcoulomb is placed, or rather I can write this one as 50 into 10 power minus 6 coulomb. I want to calculate what is the electric field at this point. I have to calculate electric field at this point, say point P for us. Now to calculate the electric field, we know the expression of electric field in terms of position vectors. You have already studied. This will be K into the charge divided by vector R minus R naught whole cube magnitude into vector R minus R naught. This is the expression. To calculate the electric field now, I need to simply substitute the value. So let me calculate what is first R minus R naught. I have the value of R and R naught. So therefore, R minus R naught will be equal to, for me R is 8 I cap minus 5 J cap minus R naught is for me 2 I cap plus 3 J cap. This works out I minus I. So 8 minus 2 is 6 I cap, and this happens to be minus 5J minus 3J, so this is minus 8J. This is R minus R naught. I got it. For the denominator, I have to calculate the magnitude of this one. So R minus R naught is going to be root under 6 square plus minus 8 square. This will work out 36, 64, this will be 100, and root 100 works out to be 10. And let me put this way, R naught is measured in meter. This is also in meter. As such, I am going to get this as a meter. Now, I am in a position to calculate this. So, electric field will be equal to K is 9 into 10 power 9 into charge is 50 microcoulomb we have, and 50 microcoulomb. So, 50 into 10 power minus 6, 50 microcoulomb divided by magnitude cube, magnitude we calculated. So, this will work out 10 power 3, 10 cube into R minus R naught vector. I have 6 I cap minus 8 J cap. Now, if I take this to the top, 10 power minus 3, 10 power minus 3, 10 power minus 6, 10 power minus 9, 10 power 9, so this cancels out. Otherwise, E is equal to 9 5s are 45, so 450 into 6 I cap minus 8 J cap. I can write this as Newton per coulomb. Otherwise, E is equal to 4.5 into 6 I cap minus 8 J cap. 10 power 3 can be written as kilonewton per coulomb. 6 4s are 24, 6 5s are 30. So, this works out to be 27, 2.7. So, here it is 10 power 2. E is equal to 4.5. So, this is 27 I cap minus 8 5s are 40, 8 4s are 32. So, 36 J cap into 10 power 2 Newton per coulomb. Now, if I write 27 as 2.7, then I am going to have E is equal to 2.7 I cap minus 3.6 J cap into 10 power 3 it will be, I am going to write that as kilo Newton per coulomb. So, this is the total electric field at this point P. Now, let us try to extend this problem. I want to calculate what is the magnitude of the electric field at this point. So, magnitude of electric field at P will be equal to E is equal to square root of 2.7 the whole square plus minus 3.6 the whole square. This happens to be kilonewton per coulomb, and if this works out to be E is equal to hopefully 4.5 we are going to get. So, this will be 4.5 kilonewton per coulomb, and this is the magnitude of the electric field. In the next session, I shall meet you with some other concept and we shall solve some more problems. Thank you very much.